So this is back on page 122. So reading this question, it has this again. It says identify the values where each expression is defined. Again, what does that mean? That means we're looking at where things are possible. And what can't we do? We can't take square roots or fourth roots or sixth roots or any even root of a negative number. So in part A, we look at, do we have any variables? Yes, we have the variable b. So we have to say, where is b defined? B is inside a square root. So you can't take the square root of a negative. So can you see that if b is a negative number, that would be bad? So as far as figuring out where things are defined in part A, we would say that b has to be bigger than or equal to 0. Now we just have to go through and do all the multiplication, and take your time. So first of all, 7 times 3, that's going to be 21. Then 7 times negative 5 root b. So this is the same as multiplying radicals, even though there's no radical in the first one. You're going to take the 7 and multiply it by the negative 5, giving you negative 35, and then root b is the only thing that's there, so it's still going to be multiplied by square root of b. Then in the middle, 2 times 3, that'll be 6, and we still have the root b. And finally, 2 times negative 5, negative 10, and root b times root b is root b squared. So we notice, to simplify, these are like radicals. So I'd have 21, negative 35 plus 6 will give me negative 29 root b's. And then, what's the square root of b squared? It is b, technically, absolute value of b. However, since b is already positive, it's okay, in this case, just to write b without the absolute value bars, because the absolute value bars make anything positive. But since b is defined to be only positive to begin with, you wouldn't have to write the absolute value bars. It wouldn't be wrong if you did, right? So it's probably safer to have it with the absolute value bars to remember that the square root of b squared is always positive. Because if b was always defined and you didn't put the absolute value, then it would be a mistake. But in this case, it's not needed. The second one. Again, it's asking where it's defined. So what variables do we have in the second one? We've got x's and we've got y's. We've got square roots. So x has to be bigger than or equal to 0 in order to make sure that we have a positive. Y is also in a square root. So y has to be bigger than or equal to 0 to make sure that it's positive inside. Here we've got to, I'm going to draw the arrows again. And for this one, you might want to rewrite it so you can draw the arrows for this one as well. And we're going to I'm going to point an arrow at that negative sign. And in bright yellow, so you can't really see it, write careful. We're going to, a very, very typical mistake happens in this one. And then you look at your answer key and go, what did I do wrong? It's going to be with that negative. So what we're going to do is I'm going to do this set of multiplying out. And I'm going to put it in a big, set of brackets. Wow, I want blue. It's not liking. There's blue. And then I'm going to do this multiplication, and I'm going to put it in a big set of brackets, and I'm going to keep that minus sign in between. So as far as the big picture goes, does it make sense that I'm going to multiply these ones with first? I'm going to put all those answers in this bracket. Going to multiply these ones next, put all those answers in the second set of brackets. I kept the minus sign in between. So if we work through this systematically, the first one, 3 times 3, 9. Root x times root x squared. 3 times a negative 1, minus 3, root. Oops, there we go. And then I have root x times root y, which would be root xy. And I have plus 3 root xy. And finally, positive 1 times negative 1 would be negative root y times root y squared. For the second one, I have root x times root x. That would be root x squared. Root x times 5 root y will be plus 5 root xy. In the middle, I would have that again, plus 5 root xy. Does it matter if I write yx or xy? No. Multiplying doesn't matter the order. So typically with variables, you write them alphabetically. That way it's easier to see like terms. And finally, we have 5 times 5, which will be 25. Root y times root y squared. Can you see that these two are like terms? And they are identical. One's positive, one's negative, so that'll cancel out. These two are like terms, and they'll actually get put together to be 10 of them. And the reason that a mistake is made with this negative sign right there is because you also are going to have to distribute that negative sign to everything. So, a little bit of simplifying. What's the square root of x squared? It'll be the absolute value of x, but since x is positive to begin with, this is one we can just write 9x. What's the absolute value of y squared? Square root of y squared will be absolute value of y, not what's the absolute value. Let's say in the answer before. So we get the absolute value, but since y is positive, we can just write that as minus y. Then we're going to subtract. This will just be x. Plus 10xy becomes minus 10 root xy. And 25y would become minus 25y. So distributing the negative is a major mistake that happens in this one because we don't keep the brackets there till the end. Now, do we have any like terms? Yes, we do. These ones are like terms. These ones are like terms. So in the end, I get 9x minus x, 8x, negative y minus 25y minus 26y minus 10 root xy. And